now we are given alpha, beta, gamma, and delta. Great. Alicia decides to use Euler's method to estimate future mackerel and shark population densities. The initial population densities are estimated to be this and this. Use a step length of 0.1. She uses a step length of 0.1 years. Write down expressions for m of n plus 1 and s of n plus 1 in terms of mn and Sn. Okay, this, guys, is in the formula booklet. This is Euler's method. I've got to the point now, it's taken a while, where I am glad to see an Euler's method question because I just know how to do it, and I want you all to get to that stage as well. So mn plus 1 from the formula booklet, it's mn, the previous m, plus the step, which is 0.1, times the derivative, which in this case is alpha m, and alpha, guys, is 0.549, m, which is mn, the previous n, minus beta, which is 0.236, mn again, and also Sn. And then that is the expression for m of n plus 1, and it is in terms of mn and Sn. Great. And then the Sn plus 1 is Sn plus 0.1 times his derivative, which is gamma, or 0.244 mn Sn minus delta, which is 1.39 Sn. Okay, great. That is 3 marks. Not that difficult. Okay, and then finally, we have to use Euler's method to find an estimate for the mackerel population density after 1 year. So we're going to have to do 10 steps here, guys. So we have our t, we have our mn, and we have our Sn. When t is 0, our m0 is this. This is our 5.7. And then our S0 is 2. And then we have 0.1, 0.2, and we go all the way down to 1. And we need to find an estimate for the mackerel population density after 1 year. So I need to find mn at 1 here when t is 1, which would actually be well, it'd be m11. It'd be the 11th step, if you like, because this is this is the 0. This is when t is 0. This is when t is 1. So I need to do 10 more steps, if you like. Anyway, whatever. Let us open our calculator. I'm just going to make it so I can see my 2 equations. Okay, I'm going to create a spreadsheet. I'm going to put in a t, I'm going to put in an mn, and I'm going to put in an Sn. Here, I'm going to put in my 0. Here, I'm going to put in 5.7, and here, I'm going to put in 2. Now, this guy is just going to be equal him, which is A1, plus 0.1. So when I do that, I can drag it down to here. Okay, that's what I meant by the 11th step, but it's when t is 1. Anyway, it won't matter. Then to find the next m, we have to put in this equation. So it's equal to b1 plus, and b1, guys, because it's mn, is this, the previous m, b1 plus 0.1 times 0.549 times b1 again, minus 0.236 times b1 times c1, close bracket, enter. Okay, great. Then this one equals Sn, which is c1, plus 0.1. So this question, guys, is not, this part of this question is not difficult, but it's annoying, and I can see in an exam it would be easy to make a mistake. 0.244, so just be careful. Times B1 times C1 minus 1.39 times C1 for S of n, close bracket, and we get that, right? So it kind of makes sense, well, it should, that the populations aren't wildly different than they were before. So he's close to 5.7 and he's close to 2. Both populations are have increased in the first 10th of a year. Anyway, I'm now going to drag this down. Guys, the easiest way to do it is menu, data, fill, and I drag it down to 1. There you go. Now they haven't filled in because I need to do the same here. So menu, data, fill, bring it down to here, and then I get this. So this is 6.11609. 6.11609. Therefore, the mackerel population density M is equal to or approximately equal to 6.12 to 3 significant figures. Okay, done. That is part E.